Everyone, I'm Lorenzo Gabriele, and today I want to talk about Mill, the Scala Mill tool, and how it can be leveraged to help us integrate with other ecosystems, for example, the JavaScript ecosystem, and reuse what we already have from the others ecosystems that are not Scala. So I'm starting with a standard file. This is the build.sc, which is a Ammonite script, and is the base of our build. It has in mill the canonical imports, import mill underscore mill.scala lib for Scala modules, and Scala JS lib for Scala JS modules. Let's create a module. What is a module? It's where you put your code in. Let's call it app. It's an object. But if we extend Scala JS module, it becomes a module. Now you need to install Mill to use it. There is a thing that helps us, which is if you go to Mill, to the GitHub repo, you go to releases, there are some scripts that are released together with the assembly, which is the actual assembly with Mill inside. This is a shell script that can be used. If you copy the address, this shell script can be committed inside your repository, so you can use it instead of using Mill. If you wget this script, it's a shell script that downloads Mill and stores in a directory in your computer, and you don't need to do any installation. So if someone clones your repo, everyone can use the Mill script. You have to give execution permissions, and now you can do .mill, ./mill, whatever. Okay, so if we do -ww is a watch mode, so it will compile and recompile every time you change a file. It says that we are missing two implementations because we created a Scala JS module, but we need to define a Scala version. And for example, the last one, Scala JS version, same thing, the last one. And now it compiles, but we need to do something. For example, we can say app.fastopt, and it generates a Scala.js binary, Scala.js JavaScript file we can run, but there isn't anything to run because we don't have code yet. We could create a app folder, then a source folder, and then a main and a file. Object main extends app, print line hello as usual, and it should work. Hello world. It's pretty fast too, which is cool. Now, imagining that you have a index.html file, HTML, and you use your Scala.js file, but you want to add some external thing as SCSS. SCSS is a a language that compiles back to CSS, and we want to use the SCSS compiler inside our project without going out from and using continuing to use mill. What we do, instead of hiding the installation part of SCSS, we can use the same package JSON we use in a JavaScript project. So we could do an npm install save dev Sass, and we have it. Now, since we installed, we have a node module folder, and here we have the Sass and we have Sass.js. And this is the actual binary module Sass help. Like this, we can see how it works. It takes a list of one of the ways you can run it is with a list of input colon output file, and we can try to replicate this on mill. So mill is very powerful regarding caches. So everything you do with mill is cached by default, and this helps us because we don't want to run Sass every time, but we want to run it just when we need it. So what we do is we create a task like build Sass, and tasks are created with a T like this. And in this task, we want to say run this compiler like this using the OS proc. OS is a library, OS lib, that you can find OS lib here. There is nice documentation about it, etc., etc. .call pvd, we call it in this directory, and this way you call the binary, but we need to pass the actual files in the format we saw there, in this format. So what we do, we need first to take the files, and mill has this concept of input that is the input of a task. Input is needed. First you need to define it with t.sources, and here you pass a list of pathref. Pathref, what is pathref? Is a class that is built around a path, and has a like hashes automatically the path, and so mill can know when the file changed. What we want is to have a directory in our repo called Sass, and inside this directory we want to create our Sass files. For example, HTML, I don't know, CSS, background color red, say. What we want is to take these files inside, all the files inside this directory, and to compile it in a task. So to get all these files, we say ospvd slash sass, and then we walk means to list all the files and recursively. Then we filter because we want only the files and not because if you try to do this, we can just, for the sake of doing it. We can print line E. Let's see what happens. This is wrong because we need to map and create a path ref. How you create a path ref is easy. We pass the you pass the path inside the constructor, the method apply, and obviously we need to call this build Sass input, and yeah, we have one file. If you have if you could if we create another file, it should be listed here. Yes, as you can see, as we can see, every time we save the file, it regenerates because it's tracking the files, which is cool. But there is a problem. If we have a directory, the directory is not filtered out because it's listed here, and we want only the files, not the directories. So what we do is we filter not is file, which is a os.isFile is a method that you pass a file and you say if it's a file or a directory. Filter not is file. Wait. Because we're printing here. Correct. So now we have all our files. This is the input of our task. So if we do here, if we do like this, with this parenthesis, we can get this input. Which is cool. Now what we want is the output. This is the input. We want the output. To have the output, we say that input path refs are this. Then I do inputs are these path refs. Let me think. So we want to create this string. Let's see it again. Not here. We want to create this string. So we want input CSS as CSS colon output as CSS. Okay. So what we do? Okay, let's do this. We have this input ref. We want to map them for and with this path ref, what we want to do. First we want the path. Input path maybe. Path. And we at least this compiles. And when we have the path, we want to change. First, we want to put the output inside the build Sass task, and the build Sass task creates a folder here. We didn't because we didn't run it yet, but if we run, it generates a folder with a dest inside. We want to get this dest, and you get it like ctx.dest. Yeah, exactly. It generates a dest. Now we want this slash the CSS files. So what we do is we get the input path and we relativize it. So if we print here input path, let's not do this for now. So this is the input path, which is obviously wrong. We want not filter not, but filter. So we want only the files, exactly. Now we want to relativize to get only this part, because we want to generate the output. So if we do dot relativize path, or to, I guess it is, to os.pbd slash scss, maybe Sass, I don't remember. Sass. Relative to. Okay, now we have the relative paths, which is what we want. Now we want to change the extension to CSS. So what we do is let me think. Ext is just the extension. What we want is, so this way is a path. Last, we get the last string. Then we get a strip when we do strip suffix. And then we do, so we have this path here. P, say, or relative dot last, and then we strip the suffix relative dot extension next. Okay, and then we do plus CSS. Okay, we have the file. This is the file with CSS. Now what we want is relative dot slash os dot up to get the upper slash. Okay, so we want the folder that contains relative, and then we want to add this. Obviously there is no folder because it's a relative path, but we want to, instead of relative here, we want to put just like this, and this should be the output path. Scala example Sass out app build Sass test main dot css. Exactly. Now we have this is the val output path, and now what we want is to create that string as we saw, with a colon in the middle, input path. Maybe we don't even know that, we don't even need the braces. Input path, output path, and then maybe we can print it. Okay, so we have the strings. Now if we pass this string, it's a sequence, so we need to to pass it here. I don't know if we can pass a sequence here. Sequence. Let's see. Boom. We generated our CSS files. Now if we change the value here, blue, it generates again. We save, and it's almost instantaneous. The only problem that I see in this solution is that we, how can we call this input output files, maybe file string. Okay, the problem I see in this solution is that if we print the file string, we have main and dest. Now if we change main, we are calculating for main and for A, but we changed only one. So if we have 100 files and we change one file, we have to recreate the CSS files for all of them. But this is suboptimal. So we want to generate only for the files that actually changed. Sadly, Mill doesn't support this as far as I know, but there is a workaround we can use, and the workaround is a little bit ugly, but it works, seems to work. The idea is that we store a map, say a mutable map. We import mutable map, mutable like this, and we say mutable map dot empty from paths to int, and for every file we store the hash of the file every time we generate this CSS. So the idea is this: we generate the CSS and we generate the hash. We save the hash that Mill has of every Sass file. This hash is something that Mill does automatically and is stored here. Value hash, inputs hash, and I'm actually is this one here. And the idea is that you save this. Next time you check if it's the same, you don't recalculate, don't regenerate the file. And let's see how to do it. So first of all, we want to save. So every time we generate something for some files, we want to store the new version of the map, and we can do for every file because it's not a costly operation. So what we do is for every input in build Sass input, what we do is say map of the input path. So for that path, which is, as we can see it again, for every path we store this. Which is called seek. And now we can print line the map. So it says like this. Now what we want to do here, instead of when we calculate the input, instead of saying give me and use all the inputs, we want to to filter them before, and we say dot filter input path ref, and we say yeah, the input path ref, we say if the map dot get of this path, so this the path, if contains, because this returns an option, so if it's false, false. If it's true, it should contain the sig that we saved. I mean, the map should contain the sig that is currently the mill currently has, and it's this dot sig. If this is true, sig is not a member of SAC. So input refs, because it's ref, yes. And now what happens? It happens that that if the sec is now empty, if we print, it's an empty sec, so we're not passing anything here, so it doesn't make even sense to run this command. So what we need to do, last thing we need to do is that if file set is non-empty, we do the actual command, otherwise we don't do anything. Else we don't do anything. But since here we need to return unit, we do this thing here. Okay. So what happens now? Now no file changed. What I'm checking here. So let me change a file, save, and we're returning 0 files. Why? Now we are returning all of them. I think I messed up. Yeah, because I'm saying all the paths, give me just the one that didn't change, but is exactly the opposite. Yeah, I want the files that did change. Okay, so let me check. Now, first I ran for all of them. Now let me change one file, and this map I don't want to print because otherwise it's very hard to read. So main and A. Now let me change main. It should return, yeah, exactly. So now it's calculating just for main. If I save, the file didn't change, I'm not recalculating anything. If I change, the file changed, I'm recalculating this. If I change A, I'm recalculating A, which is nice. And let's see, now I want to see it actually in action. So yeah, it's not nominar. Okay. Let me do, if I remember how to write a link. Nice. Out slash up slash build Sass test main.css. Actually, the file is not here, which is very strange. Let me try something. file should be here. And the file is here. Oh, I know. So what's happening is that the every time you recalculate a target, Mill cleans up the destination directory, and this is something we do not want. And if you read the tasks documentation in Mill, there is a thing called persistent targets, identical to targets, except that the test folder is not cleared between runs. We want exactly this. So let me change this, and now it should do what we want. Let me change this to red, and the main is here, and the A is here too. Cool. Now let's go here. Oh, let me put blue again. Sorry. There you go. Okay. I hope you liked the video, and I hope you enjoyed and appreciated how nice it is to work with Mill. I really love this build tool. I think it's very easy to use. Once you get the few concepts it is built around. And well, see you in the next video.